At this point, you might already be using CAD to design and even 3D print some basic parts for your project car, but internal engine components are a completely different story. We're here with Christian from Nitto Performance Engineering to get some insight into designing internal engine components and how 3D printing and 3D scanning are used in the process. Okay, Christian, just wanted to get an idea of the entire design process from start to finish on a precision internal engine part. Can we walk through looking at your conrods here? How do you start a project in terms of getting ready to design the part? Are you working with 3D scans and then bringing that into CAD?
So basically what we do when we're designing a connecting rod, we'll purchase the engine block that the connecting rod comes out of. We'll buy an OEM style an OEM connecting rod. And what we do is we CMM the connecting rod. So that's put through our Zeiss Calypso CMM. We get all the critical measurements, center to center, big end bore, pin end bore, everything that we need. From there, we take those measurements, we draw something up in CAD. We use Fusion 360 as our choice of CAD software. From there, what we do is we then run our FEA simulations. Once that passes our tests, then we 3D print the connecting rod. We take that 3D print, fit it to a crankshaft, fit a piston to the connecting rod, spin it inside the block, just to ensure we get that physical validation, make sure everything spins correctly. And then once all that's validated, we get a prototype set made, and then we get them tested in the real world.
Cool, a lot to that process. I want to come back and unpack some of those things. CMM that you discussed, can you break down a little bit more for those who aren't familiar with a CMM, what exactly that is?
Yep, so CMM is the acronym for Coordinate Measuring Machine. Now what a coordinate measuring machine is, it's a machine with a probe, and more or less what it does is it takes extremely accurate measurements of the components that you're working with.
So you're using that to map out the original connecting rod and get all the dimensions as perfect as possible for that and bring that into CAD?
Yep, that's exactly right, because once we have those perfect dimensions, we then go and model the connecting rod around that.
And then when you bring that all into CAD, you mentioned you're using Fusion 360. Are you creating an assembly there?
We do create an assembly, so we have our crankshaft drawings, piston drawings, connecting rod drawings, of course, and we do create an assembly. Again, for the shorter connecting rod engines, it's extremely imperative that we run something as simple as just a normal motion study, just to ensure that the piston isn't hitting a counterweight, a connecting rod pin end isn't hitting a counterweight. So they are very important things that commonly do go overlooked, unfortunately, by a lot of people.
So that's one of the kind of key powerful uses of CAD, is being able to get validation in a virtual world before you then go and do anything in the real world.
Yeah, absolutely, definitely.
Yeah. And then moving on from that, the next step being prototyping, which kind of serves the same purpose. You said you're using 3D printing. Specifically, what type of 3D printing are you using?
Depends on the application, but when we're talking about connecting rods, crankshafts specifically, we use SLA resin printing.
So why use SLA resin printing in that case for those parts over the more kind of typical and accessible FDM?
We opt to go for the resin printing purely down to precision, and the surface finish is nicer. So when you have things on display on days like today, it does look very nice to look at.
And obviously it's not being used for any kind of structural purpose other than assembly, so the strength doesn't matter.
No, strength definitely doesn't matter at all. Although you can print a lot of very sophisticated materials out of resin nowadays.
And then, so you're assembling all those parts in an engine block with a 3D printed crank, or in some cases maybe the actual crank, and then the 3D printed parts, get all measurements from that and make sure everything ends up where you thought it would in CAD?
Yeah, precisely. So as you mentioned, the physical fitment of the components is just a real world validation of what we saw in CAD.
And then jumping back, I guess, before you get to that prototype stage, you mentioned stress simulation, FEA, when you're developing the design. How do you know what type of loads the actual connecting rod's going to see?
Well, we have a lot of data from our own experience having a workshop in the past, as well as our good relationships with the workshops, our very close dealer workshops that we work with nowadays. One thing I must stress though is when simulating components, the program may generate the numbers you want to see, but sometimes simulation doesn't always match up with what you see in the real world. How often do we see with Formula One and things like that? They run all their simulations on their aero components and then they get to the track and the thing doesn't go any better. So real world validation is the primary importance for us.
And what software package are you actually using to do that simulation?
Fusion.
All done inside Fusion?
Yeah, we really enjoy it, man. And Andre said time and time again in some of his other videos, if you put garbage in, you get garbage out. If you know how to use the program, it's very, very effective.
And in terms of actually setting up that simulation, are you calculating that based on internal cylinder pressures that you're expecting to see?
Yep, exactly right. And we get all of that from, as I said, logging that we've had in the past and loggings that our dealer workshops share with us.
And is that all set up just as a static study rather than dealing with harmonics or anything like that?
We do static and non-linear stress models, so they form the basis of our simulations.
And then once you're happy with that, you move on to that 3D printing stage. When you're happy with it from there, are then you using your CAD model to go into the manufacturing process as well?
We use a different manufacturing software. Mastercam is what we choose to use. So from there, it's taken into there, only because some of the capabilities in Mastercam are a bit more comprehensive than in Fusion. But for basic stuff, Fusion is still very, very powerful.
And what type of machining is actually used to make the connecting rods, assuming they're forged and they're machined of some sort?
Yeah. So what our factory does, we take the 4340 piece of double melted 4340. It's then forged, put through the CNC machines, finished off in sun and honing machines, iron nitrided, then CMM'd, and then the connecting rods come to us.
And then I assume from that process, it's somewhat of a cyclic process of development and so on. What do you generally bring anything back into CAD from there and make any changes?
Generally speaking, not really. Once it's all designed, validated, and we're happy with everything, it doesn't really need to come back, no.
I guess that's what comes down to doing that initial stress simulation and then prototyping as well.
Yeah, that's exactly right. You do it once and you do it right. So sometimes what we do can take a little bit more time than others, but when we put a product out there, you know it's going to be right from the get-go.
Well, thanks for your time. I think that gives people a bit of an insight into using CAD and the likes of 3D printing when developing internal engine components that obviously need to be suited to much higher tolerances and stresses and such as well. If people want to follow along with what you're doing, see your products, where are they best to do so?
Best places to follow us, Facebook at Nitto Performance Engineering, Instagram at Nitto Performance Engineering, and our website www.nitto.com.au.
Perfect. Thanks for your time.
Thank you very much.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.